All right, so we're going to do 5.3, which is finding the area of what are called sectors of a circle. So a sector of a circle is like a slice of pizza or a slice of pie. It's this whole piece is called a sector. These notes should look really familiar. They look almost exactly like the 5.2 notes, which was finding the length of an arc of a circle. Well, when we did that, the arc was this piece right here, just the edge, which was a fractional part of the whole circumference. Remember doing that? So if we talk about it as pizza, the length of the arc was kind of like the length of the crust, just the crust part. Now we're going to be doing area of the entire slice pizza, okay, the whole area. So whereas in the last lesson you did the fractional part of the circumference, now we're just going to be doing the fractional part of the area. So okay, so they're telling us that the entire area of this whole circle is 48. Okay, what we're going to do is figure out portions of it. If the central angle is 180 degrees, then we're finding the area of that sector. It's a half of a circle. So 180 out of 360 is 1/2. So the area of the sector is going to be 1/2 of the total area. And since the total area is 48, half of 48 is 24. Now don't forget that area is in square units. So just like we did before, if we do 90 out of 360, it's 1/4. So now we're talking about finding the area of 1/4 of the circle. So the area of this sector will be 1/4 of the area. Remember, you're multiplying here. I saw a couple people put like equal signs in between their fraction, but you're actually multiplying 1/4 times whatever this area is. So 1/4 of 48 is 12. Again, we probably don't need to write all these out again because they're exactly the same as we did before. But the area of this sector would be 1/8, so 6. And then remember, 120 out of 360 is 1/3. So 1/3 of 48 is 16. Now, all of these fractions came out really nicely reduced and pretty. If it doesn't come out nice and reduced and pretty, you can still find the area of the sector. What if you had a fraction that was like, let's say, 42 degrees out of 360 degrees? Well, that doesn't simplify really nicely, right? But what could we do? Let's look at our calculator. Oops, need all that. 42 out of 360 right? 42 divided by 360. Not too pretty. But if we know that our area is 48, what could we do with this decimal now? I mean, if we have a calculator, we could just multiply it by 48. So if our area is 48, 5.6, right? So you can do, you know, funky things because you have your calculator to help you. Most of the fractions that we'll have will reduce nicely. Let's see what this actually reduces to, because, you know, we're smart enough. We know how to reduce a fraction. What goes into 42 that also goes into 360? Okay, 6 is a good one. 2 would have worked, but we'll get there faster if we take bigger numbers. Divide by 6, and we'll get 7 over 60. Can that be simplified any further? No. But, you know, you should be able to simplify these things. Do you, did we talk in here about the fraction decimal button on the calculator? No? Okay, so you could use your calculator's buttons, the smarts of your calculators, to help you reduce these things. 42 out of 360. Okay, that didn't work. This calculator is super sensitive. Now, if I want that as a simplified fraction, I can push math, and then see that first button is fraction, and then enter, and then it gives me the reduced fraction. So if you ever need to simplify a fraction, or if you have a decimal and you want to know what the decimal is as a fraction, you can turn your fractions and decimals into each other by using these first two functions when you push the math button on your graphing calculator. The little blue calculators will turn fractions to decimals as well. If you look at, it's the PRB button on the blue calculator, the little blue calculator. PRB, it's right sort of diagonally down from the blue button. And it's an inverse function, so you have to push the blue button first, and then you'll see above it, it says F to D and D to F. That's fraction to decimal, decimal to fraction. So that's sometimes comes in handy, even though you should make your brain do the work sometimes. The more you practice it, the better you get at it. I just made that one up as you know, an example of one if it doesn't come out super nice. So yeah, that was just this was just an extra example. Okay, so let's do this one down here. What's the area of the shaded sector? So 135 degrees is the degree measure of this arc. So first thing we need to do is know the area of the entire circle, and we need to know the fractional part of the sector. So let's do area of the whole circle first. Radius they give us is 8, so we're going to do 8 squared, which is 64. So area of the whole circle is 64 pi. Now this says leave in terms of pi, so I'm going to leave that pi right there. That's the area of the whole circle. Now I need 135 out of 360. So we could simplify this ourselves, because we want our brains to keep working. If I divide top and bottom, what goes into both of these? 5, right? That's probably the most obvious one. 5 into 135. Remember, think 5 into 13 first. How many times does 5 go into 13? 2. With how many left over? 5 into 13 goes twice, which is 10, right? With how many left over? I'm going to put the little 3 right here and then think of 35. How many times does 5 go into 35? So it's 27. Okay, 5 into 360. Well, 5 into 36 goes how many times? 7, with 1 left over, and 5 into 10 goes twice. So we got 27 over 72. What goes into both of these numbers? 9, right? You guys know that every time a 2-digit number adds up to 9, it's divisible by 9, right? So 2, 7, and 7, 2, they're both divisible by 9. This is going to be 3 over 8. So this is 3/8. 3/8 times 64. Remember, it's 64 pi. Think of it as over 1. Now we can simplify this. There's an 8 on the bottom, and there's a 64 on the top. Remember, when you're multiplying, you're basically multiplying straight across the top and straight across the bottom. But if there's anything on the top that's divisible by something on the bottom, you can simplify any numerator with any denominator. So 8 and 64 can both be divided by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. So now we have 3 times 8 on the top and 1's on the bottom. So the area of the sector is 24 pi. No calculator necessary. Okay, you guys try example 2. So you should have gotten 36 pi for this one. It's 40 out of 360, which simplifies to 1/9. The entire area is 18 squared times pi, which is 324 pi. Now, at this point, you want to do 1/9 of 324 pi. Basically, 324 divided by 9, which is 36 pi. And don't forget that it's square units when you're talking about area. Now, a couple of you are setting this up as a proportion, which is another way to do this. If you think about, excuse me, if you think about the degrees versus the area, and you think about part over whole, you can set up a proportion where you're doing the part degrees, which is the 40, over the whole degrees, which is 360 around a whole circle, right? And then the partial area is what we're trying to find, and the whole area is on the bottom. So you can do it this way. Then when you simplify your fraction and you get 1/9, you just cross multiply and solve for x. So you would get 9x 9x equals 324 pi. And then divide both sides by 9, and you'll get x equals 36 pi. So that's another way to do it. If you like thinking about things as proportions, part over whole equals part over whole, then you can think of it that way as well. Okay, we're not going to do the whole back of this, but I do want to point out a couple of things. The first ones are just practicing finding area. But these two word problems here, Jerry has a lawn sprinkler that sprays water out into a circle. You guys seen these sprinklers before? They usually like click around and then switch back and click around. So sometimes they just go a sector of a circle. Sometimes they can go all the way around. This one is set to go all the way around. The diameter of the circle that it sprays is 10. So 10 feet. So how much area can they cover? So this is literally just finding the area of a circle. Okay, this is the one that I like because sometimes when this is on a standardized test or a test or whatever, sometimes people are confused, like, well, how am I supposed to know? But think about this. If a dog is on a leash and the leash is attached to the stake in the ground. So here's the stake in the ground, and here's the leash, and here's the dog at the other end of the leash. What is the area that the dog can move around? Well, if he's extending the leash straight in any direction, he basically has a circular area that he can. I've seen this written as like a cow is grazing, you know, blah blah blah. They do this type of a question a lot, but understand that it's just finding the area of a circle. And what is the radius of this circle? 8. The length of the leash is basically, it gives you the area, the radius of the circle, and then you use that to find the area. Okay, so down here I would like you to try to do number 9. Actually, I take that back. Let's do 10. Let's do 8, 10, and 12. Practice these. Okay, let's look at 8, 10, and 12 answers. This was 45 out of 360, which is 1/8. The total area is 10 squared pi, which is 100 pi. So, in exact form, since 1/8 of 100 is kind of a nice decimal, not perfectly whole number, but it comes out to 12.5, you can leave this as 12.5 pi. If you want to leave it as a simplified fraction, you would just get 25 pi over 2. And that's fine too. Okay? Number 10, be careful because the shaded region is this entire piece. And so it's 120 plus the 180, so it's actually 300 degrees out of 360 degrees, which is 5/6. Now, the area is radius is 12, so 12 squared pi, or 144. So now we need 5/6 of 144. Now, again, you can do this by canceling the 6 with the 144 and reducing it, and you can do it that way. Some of you are having trouble doing that in your head, or without a calculator, so you could just do 5/6 in your calculator. I'll show it just so that everybody sees. Why did that close out? 5 divided by 6 . Oops. You could just do 5 divided by 6 and then times 144. 120, don't forget to stick the pi on at the end. And again, it's area, so square meters. Number 12, the radius is 10, so the area is 100 pi. 90 degrees is 1/4, so 1/4 of 100 pi is 25 pi square centimeters. Okay, so whether it's fractional part of the circumference, that's arc length, or fractional part of the area, you still need the degree measure of the arc, right? So processes are pretty much the same either way. Okay.